Hi, everybody. We're going to be taking a look at an example integral defined function free response question. If you remember, these are the questions where you've got some kind of graph. Notice we have the graph of function f right here. And they talk about function g, and g is the integral from -3 to x of function f. So I call it an integral defined function because it's explained using an integral. First thing they ask us to do here is to find g of 3. Notice g of 3 is just going to be the integral from -3 to 3 of function f, okay? And all you should have to do there, since it's an integral, you're just finding the areas of the different regions. So this is a little, what is that, a 3x4 triangle. It's going to have an area of 6. This little 2x4 triangle, it's going to have an area of 4, okay? So this triangle here has an area of 10. And then if you notice, you've got this little triangle down here. If you check the slope, you've got a rise of 4 and a run of 2. That's a -2 slope. So if you go over 1 and down 2, you've got a little triangle here that's a 1x2 triangle. Its area would be 2 if you take half the base times the height. But be careful, that's a negative region down here. So you've got the area of the big triangle, which is 10, and then you're removing the area of that little triangle, and you should end up getting 9 there. Okay, for part B, I'm going to go ahead and take a look at part B right now too. For part B, they ask you to figure out when the graph is both increasing and concave down, the graph of G. Okay, remember, a function is increasing when the derivative is positive. Okay, and it is concave down when the second derivative is negative. Okay, so I don't even think about that graph or anything like that. I think about that first. Okay, so what I need is the derivative here. Well, the original function is an integral function from -3 to x of f of t dt. Okay, so if I take the derivative of an integral function, the derivative of an integral function is just going to be f of x. Remember the second fundamental theorem, okay? So g prime is the same thing as f, okay? Anytime I'm answering something about g prime, I need to look at f. If I need the second derivative, which I also need, that would be the derivative of function f, which would be f prime, okay? So anyway, if we take a look at this, we need to figure out when g is increasing, okay? That's when g prime is positive, okay? That means that function f needs to be positive, okay? And we can see here function f is positive all the way along here. Actually, it's positive everywhere from -5 over to 2, okay? So anyway, second of all, we want it to be concave down, so we want the second derivative to be negative. Okay, the second derivative of g is the first derivative of f. Okay, what do I look at to find a negative derivative for f? That's the slope of f, right? So we have a negative slope here, and we have a negative slope here. Okay, so I want to combine those two things. I want f to be positive, and I want the slope of f to be negative. And the only two places that's happening is here between values of -5 and, what is that, -3? So between -5 and -3, and then it happens again, we can see that f is positive and the slope of f is negative here between 0 and 2, okay? And we can take a look here at the solutions to this. Here are the first two parts. You can see 9-point problem, 3 total points out of the 9. So they find the integral between -3 and 3. And again, it's a freshman geometry question, finding the areas of triangles. You just have to remember that you have that negative triangle region there. And then 2, notice that they talk about the graph of G is increasing and concave down on the intervals between -5 and -3 and 0 and 2, because G prime equals F is positive and decreasing on those intervals. That's how they end up justifying that.